Good morning. In continuation with yesterday's class, so we have seen what are enzymes and how are they important to the biological system. And we have also seen that the size of the enzyme is very large when compared to the size of the substrate that it reacts and so that a product has to be formed. And we have also seen that like a little bit introduction about the structure of the proteins. Like the proteins are nothing but linear chain of amino acids, and these amino acids are like how the dna is coiled bonded to such an extent so that it forms chromosome. In the same way, every amino acid chain is wound around itself to form a compact structure, and that winding has got a pattern. It is not that it gets wounded randomly. That wounding is also has a specific pattern. In that pattern the structures are divided into, so how they wound around each other, it is a specific pattern, so that is graded by levels of organization of a protein. So you have primary level of organization of protein, then secondary, tertiary and quaternary. In secondary structures you have alpha helix and beta sheets will have, and in tertiary structure we can mainly see the functional unit of a particular protein. Like I had shown you the previous picture in this. Okay. Now, so I have shown you the structure of this. So in that way, it has got, these are alpha helix that are usually present, and these blue ones are beta sheets when they are present linearly. In alpha helix, this is the amino acid chain that is in the form of a helix, and these are straight parallel. One will go in this direction, one will go another direction, and both the alpha beta, these alpha helix and the beta sheets, both are connected by loops. The yellow ones you call it as a loops. So to connect one alpha to another alpha, or alpha with beta or two betas, you have loops or turns are usually present that will be connecting both of them. Now we have seen the active site of an we have seen the active site. So active site is a, though the size of the enzyme is very large, only a part of it has got catalytical activity, and that part is called as active site. In the active site, there are two regions. One is called as a binding residue. Another one is called as a catalytical residue. The binding residue recognizes the substrate. Because it has to recognize the substrate, then only the reaction can take place. So, the binding residue recognizes and binds to the substrate, and catalytical site creates a chemical environment that will enhance the reaction rate. So what is the chemical environment that it provides is the chemical environment that is required to decrease the activation energy that is provided by the catalytical residue. Now, these are flexible. The cofactors are now, we have seen in the previous slides, I have shown you that a protein will have a enzyme will have a protein part and a non-protein part. The protein part we call it as an apoenzyme, and a non-protein we call it as a prosthetic group. It can be a metal, it can be a reducing substance, or it can be anything, but it is not a protein. The only difference is that it is not a protein. So cofactors, usually what all prosthetic groups that we see, all these prosthetic groups, they are present in the active site. All of these are usually present in the active site. These cofactors are a part of the active site. The substrate binds by non-covalent. Now, the substrate has to bind to the active site, and that binding is by non-covalent bond. If it was covalent bond, both of them will fuse together, and it will not, the reaction will not go further. So, this region is a very flexible region which can accommodate a substrate. And usually the cofactors or the activators, what all are present that are required to enhance the rate of the reaction are present in this active site only. The binding of the substrate and the components of the active site is non-covalent. Now, what are the common amino acids that we see in the enzyme site? The common amino acids, so as you know, there are 20 amino acids in the human body. So whole lot of proteins that are present in the human body are constituted mainly by the 20 amino acids. In that 20 amino acids, 10 are essential amino acids and 10 are non-essential amino acids. In those 10 essential amino acids, we further divide them into semi-essential and completely essential amino acids. Semi-essential amino acids are the ones that are required only for a specific period of time. Only for because during the growth process and all that they are required. Then after that they are not that very essential. Now how do you classify what is this essential and what is this non-essential? If they are synthesized by the body, you call it as non-essential. If they cannot be synthesized by the body and they have to be obtained by the diet, then you call it as essential amino acids. So, some of the amino acids are, now how come we differentiate between both of them? Because some of the essential amino acids can generate non-essential amino acids. For example, phenylalanine. Phenylalanine is an essential amino acid. The tyrosine is also another amino acid. Now, phenylalanine is a essential amino acid because it cannot be synthesized by the body, whereas tyrosine can be synthesized from phenylalanine. So that is why we categorize phenylalanine as an essential one and tyrosine in the non-essential group. So depending on whether they can be synthesized in the body or they have to be obtained in the diet, we divide it into essential and non-essential amino acids. So these are the list of amino acids that are usually present at the active site of the enzyme: serine, cysteine, aspartate, histidine, lysine, glutamine, and tyrosine. So these are the mainly essential. These are not essential amino acid because tyrosine is not essential, glutamine is not essential, aspartate is not essential, serine is also not essential. So these are not essential amino. Some are essential, some are non-essential. So basically, don't think that non-essential means they are not required by the body. No, they are also required by your body as much as essential ones. The only difference is that these non-essential ones can be synthesized by our body. That is why we call it as non-essential, and these need not be presented in the diet, whereas essential one has to be presented in the diet. Other than that, there is functional wise or the requirement wise no much difference between both the groups. So, in the active site, we have serine, cysteine, aspartate, histidine, lysine, glutamine, and tyrosine are usually present. Now we have seen that, okay, an enzyme is there. Enzyme enters into a reaction. Then when it enters into a reaction, it modifies in a way. Now we have also seen that what does it modify? Okay, it modification. What is its modification? How does enzyme help in bringing out? How does enzyme help in facilitating a reaction is by decreasing the activation energy. That we also have understood. Now we have also understood that the site where the reaction can take place, the site where the enzymatical reaction or the reaction can take place. So that also we have seen, that is active site. Now we have to learn how the enzyme is decreasing the activation energy. How the enzyme, we know that it is decreasing activation energy, but how is it decreasing the activation energy? So for that you need to learn about mechanism of enzyme catalysis. Now few theories have been proposed to understand the mechanism of enzyme catalysis. These are acid-base catalysis, substrate strain type of catalysis, covalent catalysis, metal ion catalysis. So these are the four methods, different methods. Like for one enzyme will be total 4 methods are there. One enzyme will use any one of these methods. So it can be done by any one of these methods. So acid catalysis, substrate strain, covalent catalysis, and metal ion catalysis. First we'll see the entropy. So entropy is the energy that is produced. So these are the 5 mechanisms by which the catalysis can take place. So the enzyme can apply any of these mechanisms and decrease the activation energy. Now, what is this acid-base catalysis? The enzymes use amino acids residues as proton acceptors are donors to aid in the catalysis process. So they will be producing, so these in acid-base catalysis, what they do is the enzymes, the residues of the enzymes, they can either accept H plus ions or they can donate H plus ions. Usually when this type of catalysis is being taken place, usually these are the amino acids that are present in the active site, like histidine, tyrosine, cysteine, lysine. So these are the amino acids that are usually present. So if this is an active site, this is an amino acid, what will it do? It will donate the H plus ion. So hydroxyl group is provided. When hydroxyl group is provided, the medium will be changed and that will help in decreasing the activation energy and facilitate the reaction. So this is a structure of OH, means it is tyrosine. Hydroxy group, cysteine, SH means cysteine, NH3 means it is lysine, amino group is lysine, and now this is histidine. So in that way, these will either donate H plus ions or these will take up H plus ions, and in the medium, whatever they do, that will bring about the catalysis and which decreases the activation energy. Next is substrate strain. In substrate strain, what will happen? The free enzyme, when it combines with the free substrate, it forms an enzyme substrate complex. Now, these enzyme substrate complex will cause strain in the active site of an enzyme, and that strain causes decrease in the activation energy. That strain and that stretch of the active site will help in decreasing the activation energy. So, in that way, the substrate will get converted to a product, and after that the product is released. So this is called as substrate strain catalysis. In substrate strain catalysis, when enzyme combines with the substrate, it will cause strain at the active site. This strain will cause in the decrease of the activation energy. So, lysosomal enzyme beta 1, for the lysosomal enzymes which break beta 1 for glycosidic linkages. The lysosomal enzymes, we have seen in the functions of lysosomes that lysosomes are very important. They help as scavengers in the body. So they bring about beta 1 for glycosidic. Glycosidic linkage means the bond between two glucose moieties, the bond between two carbohydrate moieties is broken down by this substrate strain catalysis method. Next is covalent catalysis. In covalent catalysis, what happens is a covalent bond is formed between the enzyme and the substrate. Now, when we are talking about the active site, I told you that usually the enzyme and the substrate, both of them bind. When enzyme and substrate bind, a non-covalent bond is formed. But here I am once again saying, but now here I am saying that a covalent bond is formed between the enzyme and the substrate. So what forms a covalent bond? Now here usually coenzymes are usually present. So in these reactions, there are coenzymes. What are coenzymes? Cofactors, activators, all these are the coenzymes. So the covalent bond is formed with these coenzymes. So commonly used are transamination. In transamination, we have seen that pyridoxal phosphate is the one that is required as a coenzyme, chymotrypsin and trypsin. So in covalent catalysis, what happens is that a covalent bond is formed between the enzyme and the substrate. Now, enzyme and the substrate, a covalent bond is formed. So which site, what connects to the covalent bond means the coenzymes that are usually present, they usually help in formation of the covalent bond. Now, what are the examples that use covalent catalysis for decreasing the activation energy are transaminases, chymotrypsin and trypsin. They usually use the method of covalent catalysis. Next is metal ion catalysis. The interaction between enzyme bound metal and the substrate forms a very weak bond and oxidative reactions. So in metal ion catalysis, what will happen is that there is an ionic interaction between enzyme bound metal and the substrate. So ionic interactions occurs between the enzyme which has metals in it. So now you remember that covalent catalysis happens when there are only coenzymes or cofactors should be there, and metal ion catalysis will occur Metal ion catalysis will occur when the coenzyme is a metal. So this metal, that is an ion, will form a bond with the substrate, and that weak bond will help in decreasing the activation energy. The examples are magnesium is used for kinase reactions, molybdenum is used for xanthine oxidase. In that way, all the metals which are used in the reactions, they use the method of metal ion catalysis. Next is entropy. What do you mean by entropy? Entropy means the disorderness in a reaction. So the disorderness in a reaction is called it as entropy. When an enzyme combines with the substrate, it will lead to the disorderness in the reaction. And this disorderness and the enzymes decrease the entropy. So, and this disorderness is decreased by the enzymes. So that disorderness and everything is decreased by the enzyme. So that is the mechanism by which entropy will be helping in enzyme catalysis. So now we have seen up to 5 methods by which the enzymes bring about the 5 methods by which enzyme decrease the activation energy. One is acid-base catalysis, where either acid is formed, the acid means amino acid will donate the H plus ions, or base is formed in the situation where amino acid will take up the H plus ions. That transition will be causing the decrease in the activation energy. Next, what we have seen the covalent catalysis. In covalent catalysis, a bond is formed between the coenzyme, and a covalent bond is formed between the coenzyme and the substrate, that will result in the decrease in the activation energy. Next, we have seen the metal ion catalysis, in which the metal ion will combine with the substrate, and that will decrease the activation energy. One more thing what we have seen is the substrate strain. In substrate strain, what will happen? When both of them bind, they will stretch an active site in such a way that that stretching and the strain at the active site will decrease the activation energy. Next is entropy, the disorderness when a reaction occurs, that is decreased by the enzymes, and in that way it will decrease the activation energy of that particular reaction. So this is the mechanism of enzyme catalysis. Next, we'll go into enzyme kinetics. Means to know the kinetics, what you have to see is what is happening to know about the enzyme kinetics. Kinetics means movement. Anything that we are learning about the working or activity of an enzyme, we learn in enzyme kinetics. So what do you mean by kinetics? The enzyme kinetics is a study of reaction rates, how they change in response to other parameters. So that is what is the kinetics. What are the rates of a reaction and how do they change in response to other parameters? The contact of the enzyme with the substrate is the most essential prerequisite for enzyme activity. The factors which affect the enzyme activity are, first, the contact is the one that is very essential. Unless there is contact, there won't be any reaction. Now, the factors which affect the enzyme activity are concentration of the enzyme. Obviously, when the concentration is more, then the reaction will also be very active. Next is concentration of the substrate. Then temperature, pH, duration of the reaction, activators, light and radiation. So these are the various enzyme kinetics. So what are the various enzyme kinetics? The study of the reaction rates and how they change in response to other parameters is called enzyme kinetics. The contact of energy with substrate is the most essential prerequisite for enzyme activity. The factors which affect the enzyme activity are concentration of the enzyme, concentration of the substrate, temperature, pH, duration of the reaction, presence of activator, presence of light and radiation. Why are we talking about light and radiation? Is because the light and radiation can destroy the enzyme. So that is why we have to talk about the light and radiation. Now we'll see detailedly how each factor influences the activity of an enzyme. Now, concentration of the enzyme. As the concentration of the enzyme increases, the velocity of the enzyme reaction increases proportionately. Obviously, because it is our enzyme that is required. So, as the concentration of the enzyme increases, the reaction velocity also increases. So, this will be a linear curve on an ascending linear curve. So, enzyme concentration increases, reaction velocity also increases from the origin. So, this is the concentration of the enzyme effect on the rate of the reaction. Next is concentration of the substrate. Increase in substrate, if the substrate is more, the velocity of the reaction will increase. Now here you have to understand there is first order and second order. First order and second order reaction. Now just first try to understand this. A limited amount of substrate will be present. The substrate will combine with the enzyme. It will form immediately the product will not be formed. It will form a complex called as enzyme substrate complex. Then that enzyme substrate complex will again split and it will form enzyme and a product. So write an equation E plus S will give rise to ES. Once again that will split to form E plus P. So here you can understand that in some part at one phase what is happening, the pure enzyme is not present. The enzyme that is present is bound to substrate. Free enzyme is not present. So whatever enzyme you have infused in the first step, exactly same thing you won't see in the middle because some of the enzyme is bound with the substrate. So that transition phase. So what will happen when the reaction is at initial phase? When you add the substrate, the velocity of the reaction will increase because the enzyme will combine with the substrate and all that. And what will happen in the meantime, some amount of the product is formed, enzyme is released, but most of the enzyme is locked in that position. So this is called as first order kinetics. Now, after some time what will happen, a stage reaches beyond which the reaction responds slowly to the substrate, because after some time what will happen, some of the enzyme, now initially the enzyme is E and the substrate is S. So as the S increases, the velocity of the reaction will also increase. So as the S increases, the velocity of the reaction increases. Now, when it has come to one stage, what will happen? Some of the enzyme is present in the form of enzyme substrate complex. So, though you are adding the substrate, the reaction will not increase because some of the enzyme is stored or it is locked as enzyme substrate complex. So, after some time, what will happen? It will retain a plateau and it will continue like that only. So, the state at which it forms a plateau and continues like that, that level is called as Vmax. That level is called as Vmax, and it is half of the, and the Vmax is half of the velocity of, and half Vmax is the one where the velocity is half of the maximum velocity. So when it goes to maximum velocity, you call it as Vmax. So in that way, as I told you, the enzyme is locked as enzyme substrate complex for one period of time. So because of which what will happen, even if you add enzyme also, the reaction will respond very slowly to the substrate. So that phase is called as second order reaction. That phase appears when it remains a plateau stage. So this is called as Vmax, and this plateau is called as Vmax. Now with this Vmax, the first one what we have seen, rate of reaction increases with the enzyme concentration. That is good, we have got a linear curve and that way ascending linear curve. But when we come to the concentration of the substrate, it's a little bit tricky. You can't say it as a hyperbola or parabola, something like that. But what is happening, initially it is rising, after going to a peak, then after that it is continuing like that. And for us to understand the concentration of the substrate and the relation between the substrate and enzyme should be understood very well in order to understand the mechanics of the enzyme reaction. So to that, a equation has been made which is called as Michaelis-Menten equation. So this equation suggests that enzyme catalyzed reaction takes place in two stages. One stage where enzyme and substrate combine to form enzyme substrate complex, and in the second step it will form enzyme and the protein is formed. In that way the enzyme is liberated out. So when I was talking, I was telling you is that after a period of time the enzyme is bound to substrate as E and S. It is present as E and S. That is the reason after some time the velocity of the reaction will be decreasing. Now, so this is now you have when two reactions are combining, you have an association and the dissociation constant. Now enzyme and substrate are combining to form enzyme substrate complex. So this is an association constant. Now after that this is dissociating to E and P. This is dissociation constant. Now sometimes what will happen, some of the enzyme substrate complex will be broken down and they will go back as enzyme and they will go back as enzyme and the substrate. So this is another dissociation constant. Now if you look at it, K1 is an association constant, whereas K minus 1 and K2 are dissociation constants. They are dissociation constants. So just to remember this equation, enzyme and the substrate will form enzyme substrate complex that will lead to EP. Now this K1 is association constant because it is combining both of them, whereas K2 is splitting enzyme substrate complex to E and P, and K minus 1 is splitting enzyme substrate into E and S. So this is called as dissociation constant. So in that way, when a reaction has to take place, it takes place in these steps. Now, now this Km, the Km is called as Michael-Menton's constant, and it is given by the name. So what did I do was to simply not to get things very much confused. We have divided the association constant as K1, dissociation constant as K2 and K3. Now, Km is defined as dissociation constant by association constant. So, Km is a Michael-Menton constant. The formula given as association constant, the dissociation constant by association constant. It is not forward reaction or backward reaction. It is dissociation and association constant. And after algebraic manipulations, what we get is this derivation. All this, and you have a very beautiful derivation. How did we come from Km to V0? But for this time being, this is not required for your exams. I'm not forcing on that. So after alphabetical manipulations, what you get is velocity of a reaction at any time is, you can calculate the velocity of a reaction at any time when you know the concentration of the substrate. And here in the formula you see that velocity of a reaction, for that the amount of the enzyme that is present is not required. So for the velocity of an enzyme, to occur, how much amount of the concentration of the enzyme that is present is not at all required. So it is obtained after algebraical manipulations that V0 is equal to Vmax to the concentration of the substrate by Km plus substrate concentration. Now, what is the definition of Km? When velocity of the reaction is half of the maximum velocity, then it is a concentration of a substrate. I would just like to explain this equation a little bit more. Now, this equation gives you an idea about the velocity of a reaction at any period of time. So, velocity of the reaction is equal to Vmax to the substrate concentration divided by Km plus substrate concentration. Here, nowhere we come across the concentration of the enzyme. We only talk about the Km. What is the definition of Km? When the velocity of a reaction is half of the maximum velocity, you call it as a Km. So half Vmax is equal to Vmax to the substrate by Km plus X. Now, when when the velocity is half of the maximum velocity, how the equation turns up, we'll just calculate. You have to do it by yourself, or else you won't remember the derivation, and this derivation is very much important. So in this derivation, what I am trying to tell you is, I am trying to explain you how do you define Km. Micrometer constant Km is about how to define a Km. For that, we need to understand this derivation. So Vmax by 2 is equal to Vmax to the substrate by Km plus substrate. So Km plus substrate is equal to, now this half of the Vmax will cancel off and this 2 will go here. So Km plus substrate is 2 into substrate concentration. So Km is equal to S. So how do you define that? We define Km as concentration of the substrate when the velocity of the reaction is half of its maximum velocity. So the Vmax is half of, when the velocity of the reaction is half of the maximum velocity, then you call it as a, then we define Km as a concentration of the substrate. So Km is a concentration of the substrate when the rate of the reaction is half of the maximum velocity and it is expressed in moles per liter. And this is independent of, now if you look at the Km, overall in the formula of the Km, nowhere we come across the enzyme concentration. So it is independent of the enzyme concentration and the characteristic feature of that particular enzyme. And the affinity of the enzyme to a substrate is inversely proportional to the Km, because Km is equal to the substrate concentration. If the substrate concentration is very much, even the reaction is half of the maximum velocity, that means that the affinity of the enzyme towards that substrate is very low. So here I would like to repeat you to once again. I want you, after doing that, you just try to write the formula and add the substitutes and derive the formula. You will have an idea that what do I mean by Km. Km is a Michael-Menten constant when the is a concentration of the substrate when the rate of the reaction is half of its maximum velocity, and this is usually expressed in moles per liter, and nowhere it is related to the concentration of the enzyme. The affinity of the enzyme to its substrate is inversely proportional to Km, and the Km for the, now if we take the example, so it is inversely proportional to the Km. If the Km value is too high, that means that affinity towards substrate is very low. Km of glucokinase is 10 millimoles per liter and that of hexokinase is 0.05 millimoles per liter. This shows that the affinity for the glucose towards glucokinase towards glucose is very low when compared to the affinity of hexokinase towards glucose. So the affinity of an enzyme to its substrate is inversely proportional to the Km. Higher the Km, the affinity of the substrate towards the enzyme is lower. This is about the Km. Actually, we take almost 2 classes to tell this topic if it was normal offline class. Now, I would like to, because I am stressing so much about Km, because this is a short question that would be asked in your exams, regular exams. So the Km is a substrate concentration which is expressed in moles per liter at the half of the maximum velocity. It denotes that 50% of the enzyme molecules are bound with the substrate molecules at particular concentration of the substrate. So that means 50% of the enzyme is present as ES complex. Km is independent of concentration of the substrate. Km is a signature of an enzyme. Km is thus a constant for an enzyme. It is characteristic feature of a particular enzyme for a specific substrate. The affinity of an enzyme towards a substrate is inversely related to the dissociation constant Kd. So this is a dissociation constant, the formula which I have derived, and the Km denotes the affinity of the enzyme towards a substrate. So the things that you have to remember are, it is a substrate concentration when the velocity of the reaction is half of the maximum velocity, and it implies that 50% of the enzyme is bound to the substrate. In that way, now the Km is independent of the enzyme concentration. The Km denotes the affinity of the enzyme towards the substrate. That is why we call it as a signature enzyme. That is why we call it as a signature for any enzyme. That is, it is an identity for that particular enzyme. Now, what do you mean by Vmax? Vmax are the maximum velocity. The number of substrate molecules converted to a product by an enzyme molecule in unit time when the enzyme is fully saturated with the substrate, then you call it as a Vmax. So what do you mean by Vmax? Vmax are the maximum velocity. Vmax or maximum velocity means it is a number of substrate molecules. How much substrate is getting converted to the product? How much substrate is getting converted to the product by an enzyme per unit time when the enzyme is fully saturated with the substrate. When the enzyme is fully saturated with the substrate, how much is the conversion taking place? That we call it as a Vmax. It is an index of catalytical efficiency. Now, there is one more term called as turnover number or catalytical constant or kcat. It is a number of substrate molecules converted to a product by one molecule of enzyme per unit time. So, multiple definitions are given to understand the activity of the enzyme. So, the activity of an enzyme can be represented as Km, but Km we usually use to represent the affinity of an enzyme. Now, what do you mean by Vmax? It is a substrate molecules that are converted to the product by an enzyme per unit time when the enzyme is fully saturated with the substrate. So, this kcat is nothing but the substrate molecules that are converted to the product by one molecule of enzyme per unit time. So, that is called as turnover or the catalytical site. Now, before going into this, I would like to like many of you were asking what are the reference books that have to be bought. So I'm giving you the list of the reference books that you can purchase for you. This is the order of preference. You can buy any one of these books. So these are for your regular studying. These are like your regular textbooks. Any one of them, you need not buy all the three, any one or one and two, or any two would be enough. And see that you buy the latest editions, not the old editions, because latest editions have written competency based. Past editions, because a new curriculum was not implemented, previous editions do not have competency based type of the books. Now all of these are competency based. So you ask for the latest editions, then only, even if it is late for 1 or 2 days, it's okay. But buy the latest editions. And this is being for the practical, you can get this book, and these are the reference books. So with this, I'll close the class, and in the next week we'll continue with the Lineweaver equation. But I seriously suggest you, this enzymes is a little bit complicated topic. Get the books, start reading it, or else it will be very confusing. Normally to explain the Km we usually take one whole hour of the class. But because it is online, I don't know whether you have understood or not. Just we are taking the classes like that. But if you have any doubt, you can put in the comments, or anyhow, like not more than 1 or 2 months, when you come to colleges, if you have any doubts, at that time also we can clarify your doubts.